Okay. Hello. Okay.
Okay, I am unmuted now. Hello, hello. We can start. The topic is NAT principles and common maintenance methods. For me, my bachelor is E2, physics engineering. My master is Tartu, cybersecurity, cryptography. Still continuing. Certifications, HCIE RS and CCIE RS and CCIE SEC. I am in industry till 2004. I worked at Huawei, Danske Bank, Zytek Tau, Niche Telecom, Spernline, Turkcell, CableNet, and CMC. All is for different vendors, security components, maintenance and support and installation. Different vendors, you know, Juniper, Checkpoint, FortiGate, IPSS, IBM. And here CableNet is for voice and FortiGate and Avaya voice system quality of service. This is an airport company. All locations are connected to each other with multi-vendor firewalls and IPS devices. And DDoS devices in Huawei and Turkcell. I controlled Arbor DDoS devices. And in here, Huawei, I controlled Huawei DDoS solutions. We can continue. Thank you. What will we learn in this webinar? We will talk about first inside to outside NAT, and we do a lab for it. We see how packets are translated. We do a NAT server from outside to inside. How packets coming from outside to destination NAT to the inside servers, and how we access the from internal clients, how we access the NAT server, which is normally accessed to the outside with public IP addresses. We will do a demo for this one too. So from your internal client, you will access this public IP. In presentations, we will also talk about NAT features in dual system hot backup to take into consideration, sending the blackhole conditions to prevent the loops and automation. What needs to be considered for NAT in IPsec, multi-egress and ASPF scenarios. We have slides for these ones too. What Huawei is solutions for these ones. NAT rule maintenance, which commands can be used for NAT rules operation and controls, which precautions we can take for address detection in case of malicious traffic cases, and observation not pull IP address usage and provide service continuity. These are our slides. And after the slides, we will do a demo for inside to outside NAT server and hairpin. And we talk about NAT functions, features, maintenance methods, live Q&A session, and Q&A session on the forum. This is again the summary of what we will do sequentially. NAT definitions. We will start with NAT policy working principles and deployment scenarios, NAT definition, supported NAT functions, NAT server, and smart NAT. Smart NAT is a smart solution. When one-to-one NAT is exhausting the IP addresses, you can start to port NATing. Main topic, precautions for NAT in some special scenarios. In here, we will look at dual system hot backup and load balancing scenarios, black hole routes, IPsec, multi-egress scenarios, and ASPF. And in here, the third one, we will look again, NAT address pool detection, NAT address pool statistics, NAT conflict alarm, NAT policy FAQs. For one, we can start NAT policy working principle and deployment scenarios. Here is an example about NAT. This is a source NAT policy, which we're doing from internal to the internet outside. NAT address translation, NAT from the perspective of TCP/IP, NAT translates IP addresses in IP packets. From the network application layer, NAT solves the problem of insufficient IP version 4 addresses on the internet, hides network and topology information between different areas on the network, and regulates IP addresses. NAT also indirectly improves network security because you hide your internal network. On the eve of IP version 6, NAT is an important key technology to delay IP version 4 address exhaustion. Postpone it so you can use it more. In here, if you have a private IP address, you can make it not to the firewall's interface IP address or an address pool, and then you can send it to the internet host, and internet host traffic can turn back to you with your public IP address and then translate it to your internal IP address. NAT implementation classification. IP packets contain source and destination IP addresses. NAT includes the following two types. Source address translation. When a device accesses another area on the network, the real source IP address of the access packet is replaced with the virtual IP address after passing through the firewall, not device. When 10.1.1.1 is going through the firewall to the outside, it is translated to the 1.1.1.1. If we talk about we are NATing it to the interface IP. Destination address translation. The server provides a virtual IP address for users to access the virtual IP address. After the packets pass through the firewall, the destination IP address of the packet is replaced with the actual IP address of the server. This can be used for NAT server scenario when a host from internet coming to 1.1.1.1. This 1.1.1 is destination address translated to 10.1.1.0, 10.1.1.1, or which PCA or PCB 10.1.1.2. This is for destination address translation. Destination addresses are replaced with the actual host. These are the NAT functions which are supported. NAT-T. Voice not good. I have with headphone. I don't think.
There were some interruptions. We can hear you clearly, but I think it might be the internet connection. Yeah, now I think it's better for some reason.
Okay. The firewall supports the NAT function. The firewall supports many NAT functions, including NAT-T, used for many-to-one or many-to-many address translation. Both addresses and port numbers are translated. In NAT-T, both addresses and port numbers are translated. NAT-no-path. This is mainly used for one-to-one IP address translation. Ports are not translated. Smart NAT, the firewall preferentially use the no path, like this one-to-one NAT IP addresses. When this one-to-one IP addresses is exhausted, then it will start to adding the port address translation to. We will see this in the explanation, the next slide. The reserved IP address is used for NAPT for new user connections. For example, from 1 to 5, we can use one-to-one NAT. After this 5 NAT public address pool is finished, we can start the port address translation for the 6th and 7th public IP addresses. So we can arrange it to not make port exhaustion. Triple NAT used for host on the internet or dynamically generate public IP addresses and ports for other users on the internet to access. External devices can use the translated IP address and ports to proactively access PC. This is for like peer-to-peer applications like SoulSeek. You can open your internal host to the internet, then internet host can return back to you. NAT server. Can we have one VLAN, all IP addresses to be not to single IP address? Yes, you can do. But it depends on what you are using. If you are using it more than 65,000 ports, it can be a problem. If you give DNS services, for example, and all of the internet is coming to you, they exhaust your ports. We will come this slide. It is more effective with the because there is no only port. There is destination IP addresses playing role in here too. So you can load balance this 65,000 ports, but it depends on what traffic you are servicing. NAT server used to enable private servers to provide services externally using public IP addresses. In NAT server, clients coming from the public IP address of your firewall or address group, then go to the internal host. ASP NAT, the firewall provides the ASP NAT function to perform NAT on ESP packets and set ports for ESP packets to differentiate ESP packets. We will see this on the slide. Normally ESP, there is no port for ESP. That's why firewall is differentiating it with numbering. First 16 bits and second 16 bits. We will see this explanation in slides with details. Destination NAT. The destination gateway address needs to be changed, which is often used on the web network. NAT 66 refer to translation between IP version 6 addresses. CGN NAT, including NAT 444, DS Lite, PCP, and static mapping. This is destination NAT's used areas. Here is the explanations of the previous slide. NAT translates both addresses and ports. Source IP address is translated 192.168.1.2 to 1112, and source ports are translated too, because this is translated both address and port. And destination IP address is the same and port is the same. Here there is a session table 192.168.1.2 and port 125 is translated to 1112 to 2048, and destination is the same. multiple users can share one IP address. The same user is always assigned to same IP address. The source port needs to be translated when internal and external users access the network. The port is translated to implement address multiplexing. Thank you. The port number of the NAT address ranges from 2048 to 65,535. The NAT conflict occurs. In here, multiple users can share one IP address. This means in this intranet host 24 subnet, all hosts can be translated to go outside with this IP address of the firewall or an address group. The source port needs to be translated when internal and external users access the network. The port is translated to implement address multiplexing. This is meaning the source port is translated. And the port translated from 2048 through 65,535. And in here, not no path, the source IP address translated to the firewall's address group, but the source port is remaining the same. And destination web server are again the same, and destination port is the same again. Thank you. And you can see the server map table in here. Private IP address is translated to the firewall's IP address, and the returning traffic is going as a NAT server. Because of that, there is a server map entry table is creating. 1112 is translated back to the internal server. When you see in session table, you can see the source IP and port. Only source IP is translated, port remain the same. And destination IP, destination IP and port is the same again. An IP address is automatically assigned to a user when the user goes online and reclaims the IP address when the user goes offline. Dynamic address allocation. Each IP address pool can be used by only one user at a time, one-to-one conversation. Only the user IP address is translated, but the port number is not translated. The address cannot be reused. In NAT low path, we can do one-to-one nothing, and it understands work as an automatically assignment. When user goes off online, it can take this IP. When the user goes offline, the IP address is released again. Each IP address pool can be used by only one user at a time. When 192.168.1.1 used 1112, only this IP address can use this one. And 1.2 used 1.3. All intranet IP addresses can use one public IP address from here. So this, because of that, this is one-to-one conversation. Because the traffic comes back with this public IP address and use the same port. So you cannot differentiate it with ports. You only have the IP addresses, source IP addresses translated. Only the user IP address is translated, but the port number is not translated. The address cannot be reused, what we talk about now. Here, how we do the configuration. This is both address and port translation, mode path. This is the pool we can use, address group pool. And we write the NAT policy, trust to untrust, source address 1110/24, and we source NAT it to this section, address group section. It's meaning like we see here, this intranet is translated to this IP address, and this is how we write this on the firewall. NAPT applies to scenarios where a small number of public IP addresses are used and a large number of private network users need to access the network. This port translation we can use in small number of public IP addresses we have. And more than these public IP addresses if we have internal IP addresses. You cannot use not no path if you have too much users but not equal public IP addresses to translate them one by one. That's why we need to use we need to add the port 2 to the translation. Not no path, only addresses are translated but ports are not translated. Here is again the same, but mode is no path global, so it's meaning that no port address translation will be done here. Trust untrust, again the source address block is the same, and we NAT it to the address group. Everything is the same, just the not address group 1 mode no path global we need to add for no port translation. Not no path applies to the scenario where a small number of internet access users and the number of public IP addresses is the same as the number of concurrent internet access users. If you have 5 internal users, for example, and if you have 5 public IP addresses, you can translate them one by one. So you can do not no path for equal intranet and public IP address group IP addresses if you have. Not server, not function feature, not server. Not server is clients come from internet to intranet. You can see in here source 333. Source port is the same, remain the same. Destination IP is 1112. Firewalls outside interface IP address. It is translated to 199.168.1.2 and the same port. This is the NAT server configuration, and packet can return back as the same scenario, and only source IP address is translated again. Principle: when an extranet user accesses an internal server, the firewall processes the access as follows. When packets from extranet users to intranet servers reach the firewall translates the destination IP address of the packets from public addresses to private addresses. When the return packet is returned to the firewall translated the source address of the packet from the private address to the public address. What we talk about is written here too again, and here is examples. 1-to-1 NAT server for global 111 inside 192.168.0.1. This is for 1-to-1 NAT. If the internet host comes from the firewall's IP address 111, it is directly translated to the intranet host 0.1, for example. And many-to-one NAT, again it is coming to 111 port 8080, and it is translated to internal server. And in here it is coming to the 2222.88, and it is coming again to internal server. In here many-to-one NAT, the internal host is the same, but the IP address group and which is configured in the outside of the firewall is different. So two different global IP addresses translated to the inside IP addresses with 8080 port and translated to 80 port. And no reverse, if you don't write no reverse, when you write this NAT server config on the firewall, these internal hosts can go out to the internet with this NAT server configuration without a traffic initiated from external to internal. It can directly initiate traffic from intranet to extranet. But if you write no reverse, you can close this feature. Only a traffic generated from outside to inside can return back. If this intranet host wants to go to internet, it cannot go because you write no reverse. UNR route is you send this route, this global IP route to null zero, because if this global IP address is different than your firewall's IP address, firewall's interface IP address, then this firewall don't know where is this IP address, then send it to the next hop, and next hop knows the route for this firewall's group to the firewall, then it makes a loop. That's why we will talk about this in next slides. And then you need to, if you use the different address pool than the firewall address pool, you need to write a static route to null zero to avoid this loop and CPU usage till TTL time exceeded. Here, many to one-to-many. In one-to-many with port addresses, it comes to the firewall 111. If it comes 8080 port, you can take it to the 1207 server. You can translate it. And if it comes to 3030 port, you translate it to the another server. In here, you can divert the traffic with the port addresses. You can differentiate from the port addresses in one-to-many NAT. One-to-many, one public IP address to a different hosts. Many-to-one, different global public IP addresses to the same host with same port. These are coming from the same port too, but you differentiate it in the public ports, public IP addresses ports. Okay, I think this we will see these ones in the next slides too. This is smart NAT, what we talked about at the beginning too. In this smart NAT, it is a supplement of the NOPAT mode. So it is starting with doing one-to-one NAT. Smart NAT allows you to reserve an IP address for NAPT in NOPAT NAT mode. This mode applies to the scenario where the number of internet access users is small, the number of public IP addresses is almost the same as the number of concurrent internet access users, but the number of internet access users increases sharply in some periods. For sudden peaks, normally you have internal IP addresses and external port public group IP addresses is the same. When sudden peaks come, then you start to do smart NAT for the extension of the public group IP addresses. In this example, we can see it from intranet to internet. It will start 1.2, 1.3, 1.4. For these ones, it is doing one-to-one NAT. You see the source IP address and public IP address is translated, but ports remain the same. it remained the same till 5. Then after 6, it start to use the port translation too. Public IP addresses are finished till 1 to 5. NAT address group is 5. After these are finished, it start to do the no path, smart no path. So for 1.6, it starts to change the port, source ports, translate the source ports too. Here is the configuration. Mode no path global. Mode coming at no path, so it's 1-to-1. Smart no path for 1.15, we start to smart no path, and this is the pull. Normal 1-to-1 NAT pull. NAT policy, trust to untrust for action source NAT address group 1, this one. Working principle. After receiving a packet from the intranet, the firewall selects an idle public IP address from the NAT address pool, replaces the source IP address of the packet, creates a session table, and sends the packet to the server. When packet is received, the firewall selects idle public IP address to NAT address pool, replaces the source IP address of the packet, creates a session table, and sends the packet to the server. If the NAT address pool does not have idle addresses, the firewall replaces the source IP address and port number of the packet with the reserved NAPT address and new port number, creates a session table, and sends the packet to the internet. This is what we talk. This one is what we talk about till here. Just source IP address translated, port is remain the same, and 2 is after this 1-to-1 public IP address translations, public IP address is exhausted, it starts to do not for adding port 2. This is the second one. Which here do you lost, kiddos? This one or smart NAT or NAT server? We do for demo for this one and this one, so you can catch. If I think this is clear, you can do 1-to-1 NAT for these ones. For these ones, when these are exhausted, you start to do NAT for this one with adding port translation. Triple NAT IP addresses and port numbers are translated simultaneously so that multiple private addresses can share one or more public addresses. It allows users on the internet to proactively access private network users. It can coexist with peer-to-peer based file sharing, voice communication, and video transmission services. You can see the configuration in here, mode con, full con global. These are the address group. And trust to untrust, address group 1, we noted. Here the IP address, source server map table, destination, UDP, any. If it comes to the firewalls outside address group, it is translated to the intranet group. And this is from destination UDP, and this is the reverse packet. IP address is translated to the firewalls outside IP address. And in session table, you can see the NAT address group the address group assigned to the firewall is internal address, internal host translated to the firewall's address group. Then destination is 2111 and 35. In NAT server map table and session table. We will look at this in lab, how we see the session table and server map. Local triple NAT. The server map generated by local triple NAT contains security zone parameters. Only hosts in the security zone can access intranet hosts. Global triple NAT. This generates triple NAT does not contain security zone parameters. Once the server map is created, hosts in all security zones can access intranet hosts. After endpoint independent filter enable is enabled, when an internet user proactively accesses an intranet user, the packet matches the destination server map table and then directly forwards the packets without security policy process. If endpoint independent filter enable the forward packets based on the security policy rules. This is the explanation how this destination server map table, it hits and directly forwards the packet without a security policy processing if endpoint independent filter enable is enabled. If endpoint independent filter is not enabled, the system searches for security policy rules and determines whether to forward the packet. In the first one, server map table is important looking security policy. If it is not enabled, its system searches for security policy in this time. SAP NAT. SAP is a layer 3 protocol and does not have a port. Therefore, SAP packets are incorrect when NAT that allows port translation is performed. Most Huawei Datacom devices do not support NAT for ESP packets. Improvement: the firewall provides the ESP NAT function to perform NAT on ESP packets and set ports for ESP packets. Differentiate ESP packets. SAP NAT can be used in source NAT and NAT server scenarios. In here, for SAP packets, the intranet host is going to the intranet host 3330 through IPsec tunnel. FSPI1 and FSPI2, how it can differentiate the ESP packets. 0, it cannot use the port. Here, PC1 sends the first packet to PC2, and firewall establishes the session table from intranet host to the 333 with FSPI1, FSPI2. PC2 sends the response packet to firewall 1. Yeah, not protocol number, port number, yes. It starts to write in the when PC2 sends the response packet to PC1 and the firewall updates the session table. At the beginning, it is using the port 0, but firewall in the reverse packet updated to the RSPI2 and RSPI1, the source port and translated source port. So from here, it can differentiate. What is this ESP packet? Is which host is corresponding into. When PC1 sends a packet to PC2, the firewall creates a forward session. When receiving the first ESP packet from PC1, the firewall uses the first 16-bit SPI value, FSPI1, as the source port number and the last 16-bit SPI value FSPI2 as the destination port number. The port numbers of the source and destination addresses after NAT are set to 0. These ones. So like we told already, FSPI1, FSPI2, and 0, 0. After when PC2 sends a response packet to PC1, the firewall receives the reverse packet and preferentially uses the SPI value in the reverse ESP packet as the port number to search for a session. If a match is found, the firewall considers the session to be created and processes the session normally. If no session is hit, the port number 0 is used to search for the forward session and creates the session table. The firewall divides the SPI value in the 32-bit reverse ESP packet into two parts. The first 16-bit SPI value, RSPI1 in here, is used as the destination port number of the NAT, and the last 16-bit SPI value, RSPI2, is used as the source port number of the NAT. The firewall updates the session table. RSPI2, the source port number after NAT. In here, it says after NAT because this is a diverse packet. From here, it can differentiate it. Destination port after NAT and source port after NAT. And you need to write firewall ESP not enable to make this differentiation available. In here, we can look at the precautions for NAT. Does it work? Hi. Does it work on principle of NAT, the network address translation traversal? For differentiating it, yes. Yes, because you cannot use port address translation in ESP. For using it, you need to do this one. Not exactly the same, but the methodology is different for ESP. Since you are explaining about all kind of NAT, you can talk something about CG NAT, carrier grade NAT. Invite currently recommend. It is not including the presentation. I can send you additionally this one. Okay, is ESP not Huawei the same that NAT is other vendors? NAT is not only used for ESP. NAT traversal is using for another solutions too. Surely. Okay. But it is closer. Yes. This is not precautions. for some special scenarios. Dual system hot backup scenario, do the address pool need to be bound to VRRP? VRRP IP addresses in here is 1.11. If the NAT address pool uses IP addresses on the same network segment as interfaces, VRRP needs to be configured. VRRP parameters do not need to be configured for address pools on different network segments. When PC1, let's talk about when VRRP master is 1.1 and one VRRP slave is 1.2, and you have a VRRP IP address in here. If you use only master or only slave, it can create inconsistencies. That's why you need to use the VRRP virtual IP address. When PC1 accesses the server, source NAT is performed, source IP address is translated into 1.11, which is here, the VRRP virtual VRRP address. Then the server responds with an ARP request broadcast of 1.11. Both the master and slave firewalls receive ARP packets. If the firewall does not have special configurations, both firewalls reply with ARP reply packets. If we don't do VRRP IP address inside of the VRRP IP addresses, then both firewalls reply with ARP reply packets. The server uses the last received ARP reply packet. So 1.1 and 1.2 is giving replies, and the server uses the last received ARP reply packets. As a result, the relationship between the server and the firewall to which the server forwards the packets is uncertain. Therefore, the networking is incorrect. What we can do, bind the source NAT address pool to VRRP. For example, in the preceding example, the NAT address pool is bound to VRRP2. In this way, when the master and slave firewalls receive requests for IP addresses in the address pool 10.0.0.10, only the master firewall responds with ARP reply. Active standby mode, the system automatically binds the addresses in the NAT address pool to the VRRP backup group with the smallest VR ID. Therefore, you do not need to configure VRRP keywords. Load balancing mode, generally you do not need to manually configure the load balancing mode. The system automatically binds the load balancing mode. You need to bind the NAT address pool to the VRRP backup group only when multiple VRRP of the scenarios, active standby mode or load balancing mode. So the key is in here, we need to bind this virtual IP address to the VRRP group to solve this. Without this, the packets are returning to master or to slave inconsistently, and the networking errors occur. Then we need to bind this IP address to the VRRP. NAT precautions, NAT configuration in dual system load balancing scenarios. Master backup share the same address pool. If master and backup firewall share the same address pool, you can do section 11110. Section 11110, that only one IP address, trust to untrust, and you can bind it to the address group 1. The comments here, HRP NAT resource primary group, HRP NAT resource secondary group. K configuration points, the configuration on the master backup devices must be the same. The NAT policy and address pool must be consistent. The port segments of the master backup devices must be separated to prevent NAT conflicts between the master and backup devices. Same principle after NAT. Enable quick session backup. The NAT address pool must be important to OSPF. On both the master and backup devices, return packets are randomly sent to the master or backup devices. If you want to know quick session backup means, it is here in quick session backup. If quick session backup is disabled, session backup is asynchronous. The active device packet packs session into packets and send them to the queue. It is not momentarily synchronization. Master device keeps the packets on itself, then sends with a queue. So it is a postponing, delaying send. Other CPUs schedule the packets and send them to the standby device. If quick session backup is enabled, session backup is synchronous. After a session is created on the active device, the CPU directly sends packets to the standby device and then forwards original service packets. If quick session backup enabled, master node is sends the packets to the slave node momentarily. Difference: if quick session is disabled, so master node sends the packets to the slave, then there is a delay occurring in here. And if there is an inconsistent path, the packets turn back to slave more quickly, but the slave don't know these packets at the moment because it's not transferred from master to slave. That's why the causing packet loss and inconsistency occurs in here. This is how can you do what needs to be accepted when you do the enabled quick session backup. All sessions to firewall is backed up. Only UDP sessions and subsequent UDP packets not patched, and other sessions are backed up. These are backed up. If it's disabled, sessions to firewall not backed up, TCP half connections not backed up, UDP sessions not backed up, other sessions backed up only. That's why it is important in here to catch the master and slave with synchronity with same packets. It's configured like that. This is master backup share the same address pool. If master and backup share different address pools, then you can again write address group 1, address group 2, define on the firewalls. Then for 10.3.51 to 10.3.0.100 interval, you can use group 1, and then for policy node 2, 101.150 interval, you can use group 2. This scenario is for master backup device use different address pools. The configuration on the master backup devices are the same. Internet routes are used for load balancing. Some traffic passes through the master device and matches the first NAT policy. Other traffic passes through the backup device and matches the second NAT policy. This is how this process is going. This is already obvious. Quick session backup needs to be enabled. The NAT address pool needs to be important to OSPF on the master and backup devices, so it can be aware of the routes. The priority of group 1 advertised by the master device is higher. The priority of group 2 advertised by the backup device is higher. Ensure that return packets in group 1 are preferentially transmitted to the active node, and that in group 2 are transmitted to the standby node. This is for packets going out packets, and this is for return packets. These packets needs to be translated back. That's why you need to import the OSPF route too. So this is for returning traffic's consistency. If it is not doing that, the group 1 and group 2, it cannot turn back properly. So they are corresponding address group and address source address range. These are written in the documentation too. Here is the black hole. Why configuring black hole routes for public IP addresses, not precautions? Why is the black hole route on the public address advertised? For example, if you have NAT address group 1.10 and your firewall's IP address is 1.1, you don't need to write null zero static route. But if your firewall's IP address is 10.0 and your NAT address group is 10.001, you need to write a static route to null zero. Why this is needed? In here we can see the explanation. The address pool and the interface address of the firewall are on the same network segment. This is this one. When the public network packet whose destination address is an address in the address pool reaches the firewall, if no session is matched, the firewall forwards the packet through the route. After searching the route, the firewall finds that the packet is on the same network segment as the interface address. Therefore, the firewall directly sends an ARP request packet to request the ARP of the address in the address pool. Apparently, no one responds to the ARP packet, and therefore the packet is discarded. Therefore, black hole routes do not need to be configured in this scenario because the packet is discarded. But if the IP address and address pool address are different, then firewall send it to the router is send it to the back till TTI value is 0. Here is its explanation. If the address pool and the interface address of the firewall are on different network segments, when the public network packet whose destination address is an address in the address pool reaches the firewall, if no session is matched, the firewall forwards the packet to the route, finds that the address pool and the interface address are on different network segments. The firewall generally matches the default route and sends the packet to the next hop router. The next hop router searches for the route and sends the packet back to the firewall. A loop is formed between the firewall and the router. The packet is discarded after the TTI value is 0. As a result, bandwidth and performance are wasted. Therefore, black hole routes must be configured in this scenario. Black hole routes must be configured for the address in the NAT address pool and public IP addresses of the NAT server. In a device hot backup scenario, you need to configure a black hole route for the address pool on both the master backup devices. For both master and backup devices, we need to configure the black hole route. Do you want in here, because I asked it in questions, if everything is clear, I can repeat one more in this one. If they are in the same segment, you don't need to, what is the firewall's untrust interface and the address group you configure. If they are in the same subnet, the ARP request is discarded because they are on the same subnet. Firewall directly sends an ARP request to it. It don't need to route it to find the route from a static route or default gateway. They are in the same subnet. They can communicate each other. But if it is in the another, in NAT policy, what is meaning of NAT 0 section? It is meaning of address pool. It's just written as like that. It means section 0 address group. This one is used section 0. This one is group used section 1. It's just this section is differentiating address group between each other. If you only one group, you can use section 0. If you have another groups, you can use section 0, 1. Like IP access list sequence. If it is different, when this firewall interface wants to reach 10.0.0.1, it sends it to the router, and router sends it to the back, because in here there is only destination NAT is doing. In the firewall there is a static route to next hop. Then because firewall cannot find this one, it sends it to the static route. And in router you write a turn back packet for the address group, then it's turned back here. Firewall again cannot find it, and it send it to back to the R1. Then it is going to loop. After time to leave value coming to 0, this loop is finished. But in this interval, bandwidth and performance are vested when they are different subnets, firewalls, IP, and address group. This is for IPsec scenario, overall node map. Overall map, when the firewall functions as the IPsec gateway and NAT gateway, no NAT must be configured for negotiation and encrypted traffic. Then configure a NAT policy for internet traffic. Configure no NAT for IPsec negotiation packets in both directions. This is for firewall A's untrust interface IP. This is firewall B's untrust IP. We need to write a policy between these one, NAT policy between these one, action no NAT. Packets packets needs to communicate between each other as is. There's no need to be a translation, because it affects the IPsec working mechanism if this IP address are translated. Then in policy NAT1, this is for interesting traffic. Interesting traffic should be non-NATed, because we write interesting traffic in the ACLs. If it's translated, it cannot match our interesting traffic, and we cannot make the IPsec tunnel up. Rule name policy 2. Yes, I can send you this. These are in the forum will be. These are on the forum will be. We need to go more faster. I can give this handouts too. This is how everything works, but we need to do lab too, so we must be a little bit quick. I can give these ones. This one is for source NAT, how to configure in the firewall. There is in the documentation too, but this is a very topology, and the config is very compact, very easy to use. And this one is for NAT server for coming back traffic. This is an e-learning videos. I can send their links and these ones. And hairpinning, we will talk about this too. This is ENSP router and firewalls config. I can give these ones. We will do this in lab now, if we can fit the time. In here, this is for no NAT for interesting traffic, and for remaining traffic, this PC can go out to internet with NATed to the firewalls outside IP address. this is the important part. You need to do for PC1 to PC2 interesting traffic, no NAT. For remaining traffic, you can do NAT. This is the traffic without this NAT. This is other traffic, so you can do NAT to the firewall. Here is written what we talk about. Configure no NAT for IPsec negotiation packets in both directions. This one. Configure no NAT for IPsec flows of interest. This one. Configure NAT for other traffic destined for the public network. This one. This is not configuration in multi-egress scenario. There is two ISP here, address group 1 and address group 2, 111.10 to 12, 222.10 to 12, address groups. If you want to go to ISP 1, trust zone to ISP 1 zone, you can use not address group 1. If you want to use address group 2 when going trust to ISP 2, you can, for source address is the same, you can use this address group 2. So you can use address groups based on destination zones. You can arrange it based on necessity. Trust to ISP 1, use address group 1. Trust to ISP 2, use address group 2. Configure the two public network interfaces in different security zones. This is how we can do this. In the firewall, there need to be two public IP address, 111 and 222. Configure different address pools for them with configured in here, and bind it to the public network egress. Configure different NAT policies for different public network addresses. And we assign these address groups in these NAT policies based on destination zone differences. I can straightforward to be understand. Okay. Then ASPF configuration for multi-channel protocols. ASPF can automatically detect the application layer information of certain packets and enable the corresponding access rules based on the application layer information, generating a server map table, monitoring packets during communication, dynamically queries and relating filtering rules. Monitoring packets during communication, when the related stream is passing through the firewall, from after the three-way handshake, firewall can understand the application layer protocol depending on the packets. Then it can write and understand the protocol and show it in the passing through packets. Then firewall can do a application layer configuration after that. Configuration method enable ASPF globally. Sysname firewall detect FTP. ASPF can be enabled in the intra-AS or inter-AS. Sysname interzone trust untrust detect FTP. You can enable ASPF globally, or you can enable ASPF based on the passing through traffics zones, ASs. Trust to untrust, untrust trust, or trust to DMZ. For this traffic, you can configure for detection for applications. Precautions: after the ASPF ALG configuration is modified, for example, the ASPF ALG function is disabled, run the reset firewall server map or reset firewall IP version 6 server map command in the diagnostic view to clear the corresponding server map entries. Before clearing the server map table, clear the corresponding session first. Otherwise, the server map table cannot be cleared. This is for precautions for using this functions. Disable the ASPF ALG function of a specific protocol in a timely manner. For the SIP protocol, only TCP and UDP-based SIP traffic can be processed. TCP fragmented packets do not support ASPF ALG. These are the precautions about this usage. For SIP FTP, you need to define the ASPF to firewall can understand the application and let the traffic with their related ports, because their ports coming and returning and creation are in different ports. That's why firewall needs to understand these packets applications. How do I configure security policies in NAT scenarios? Security policies are configured based on the real address of the source NAT or NAT server, not the address configured on the firewall. When configuring a source NAT policy, specify the source address in the security policy as the address before NAT, not the address in the address group. This is for if you make a one, for example, in here, if you make 10.1.1.0 to source NAT, in source NAT policy, you must write this IP address for the NAT policy rules. Inside IP address, not the public IP address of the firewall. When you configure NAT server, this is reversed. The destination address specified in the security policy is a private address after NAT, not a public address before NAT. It is again in here. If you write a NAT policy for NAT server, you will write this 10.2.0.0 destination NAT, internal IP address, not the public IP address of the firewall. So in here you can see the source address and destination address are the private IP addresses. NAT server, BBS zone, Untrust protocol, TCP global 111, FTP. This is public IP address. This is internal IP address. Rule name permit NAT server, source address, the destination address. The public IP destination match enable command enables public IP address matching in NAT server scenarios. After this command is enabled, the public network on the NAT server is used to match the destination address of the security policy. It is not recommended on live network, which may cause confusion. I think here is clear. What security policy needs to be written? Destination address is the private one, which is after NAT. Like here is said, when you configure NAT server, the destination address specified in the security policy is a private address after NAT, not a public address before NAT. This NAT is destination NAT. When it comes to 111, it destination NAT to 10.2.0.0. And for this one, it is again the private IP address, source address, not the public IP address after NAT. It's meaning when configuring source NAT policy, specify the source address in the security policy as the address before NAT. Here NAT is source NAT, private IP address before NAT. It means NAT policy maintenance method and FAQs. This will come in questions too here. Public address before NAT and address pool security policies in private IP address into scenario. NAT policy maintenance methods and FAQs. Here is the troubleshooting and operation commands. Rename a NAT rule, rename old name, new name. Change the position of NAT rule. If you make it to the go to top, for example, rule move, rule name, top, bottom, up, down, or after this rule, before this rule. Clone a NAT rule, rule copy, rule name, new rule name. You can disable, enable a current NAT rule. You don't need to on the old configuration and need to configure it back. You can disable, enable it. Operations, check existing NAT address pool, display NAT address group, name, all systems, ID, check NAT policy rule configuration, display NAT policy rule, display NAT policy rule verbose. This is for checking address pools. This is for NAT policy rule configuration. We need, if we want to see NAT policy rule configuration, NAT server configuration, display NAT server, all systems, ID, name, display NAT server, MIP index, display destination NAT address group, view the configuration of destination NAT address pools. These are the operation and troubleshooting display commands, display destination NAT address group, display NAT server, display NAT server, display NAT policy, display NAT address group. This is NAT address pool detection. If one internal client, how to configure for VoIP signaling RTP, nothing. With SIP protocol detection. Then firewall can understand. Yeah, yes. Then firewall can detect it and let the corresponding ports to pass through. And from your globally or zone, interzone, through interzone which you want to communicate, or globally, you can open it. I need to write corresponding NAT server rules, not source NAT rules, NAT server rules to come back. Configure NAT address pool detection. If one client is doing some malicious things, then the outgoing interface public IP address is added to the malicious address list on the internet. Then another legal legitimate traffic from intranet to outside cannot be permitted by internet sites. That's why we have a detection, IP address pool detection, NAT address pool detection mechanism. This mechanism is periodically sent probe packets to the remote server. If the probe from the address pool, if this packets get no response, then if 15 seconds by default, 3 detection packets are sent. If this 15 seconds for 3 detection packets, 45 seconds, if it cannot take reply from the server, then this address pool's member is removed from the NAT address pool, and another customers can go out with another pool members so they can reach the internet, and this deleted IP address still continue to probe, and if can get a reply, it will be added to the address pool again back. The NAT address pool detection function is implemented by referencing a health check template in the address pool. Sysname address group NAT address IP detect health check detect 1. Here we can see which IP address is excluded, which can still working. These ones, for example, excluded yes, excluded time. In this time, they do a malicious activity and they are excluded from the address pool. This one is safe and continue to transfer legitimate traffic. This is still on address pool members. We can understand from there. Display not IP detect address group name NAT address. Configuring NAT address pool statistics. To configure the NAT address pool statistics function to learn the usage of the address pool, which facilitates address pool management. The NAT address pool statistics function periodically collects statistics on address pool information, including the total number of public IP addresses, total number of private IP addresses, maximum number of private IP addresses, corresponding to a single IP address in the address pool, maximum number of stations corresponding to a single IP address in the address pool, and total number of established stations in the address pool. The statistics help you learn about usage of address pools and manage address pools better. How we can configure it? NAT statistics enable, NAT address group 1.3 mode path statistics enable. And we can see it display NAT statistics address group name test. Then it can show us our global IP address 1, address group 1. There is 10 inside IP. Global IP address is 111. There is 20 station. So we can decide and show the usage. If the IP addresses is consumed, are overused, we need to add new pool members. We can understand from these results. NAT conflict alarm. HV sec trap not over threshold. Alarm is over the threshold. The NAT conflict rate of pool name, system name is exceeded the upper threshold. Slot CPU. The total number of NAT conflicts exceeded the threshold. Impact on the system. The firewall selects a public IP address based on the source IP address in hash mode and selects the port number in polling mode. Before selecting a port number, the system checks the session to determine whether a port conflict occurs. If the port conflict occurs more than 16 consecutive times, the public IP address and port number are insufficient and packet loss occurs. Possible causes. The number of ports used for NAT is greater than the number of available ports in the address pool. Handling procedure. Add an IP address to the address pool. Run the display firewall statistics system discard command in the user view to check whether the number of packets discarded due to port conflict. This is what we talked about in the beginning, this 65,000 ports exhaustion issue. It can analyze it by its default metrics 16 consecutive times, and it can decide it if the ports are overloaded or not and give you alarm. Increase the number of IP addresses in the address pool based on the packet loss rate. You can decide it how how many new address group members you need to add based on packet loss rate. Enter the address pool, not address group view, and configure an address segment section. So we can increase this section in here if we have not address port exhaustion problem. Does the firewall support source NAT configuration in transparent mode? Service interfaces working in switching mode? Supported, but only the address in the address pool can be used as the source address after translation. The outbound interface address cannot be used as the source address after translation. Why? Because it is a transparent mode. We cannot use the firewall's IP address. We can use only the address pools IP addresses for it. Firewall arrange them. But the outbound interface of the firewall cannot be used because it is in transparent mode. So there is no IP in here for routing wide in the network. If multiple NAT policies are configured in a NAT policy, what are the matching rules for packets? If multiple NAT policies are configured, the device matches the policies from top to bottom. As long as the strategy is matched, it will not continue to match the remaining strategies, regardless of whether the action of the policy is NAT or no NAT. It's going to top to bottom, and if it hits, it can do the scenarios in there, don't go to bottom more. Whether the addresses in the NAT address pool must be consecutive addresses. No, it is not needed. It can be 10.001 and 10.001 start and end addresses can be the same. So it can be only one IP address. Can interface IP addresses be used for NAT server or source NAT? If the global IP of the NAT server uses the interface IP address, packet, if you use the firewall's IP address as a NAT server, if you want to manage the firewall, this public IP address cannot let you to manage the firewall, but it makes the port translation to the internal server. So that's why some conflicts can be here in here there. If the interface IP address is used as source NAT policy, the packet goes through the first packet process when the user proactively accesses the interface IP address of the firewall, which is not affected by source NAT policy configuration. You can use source NAT, but in NAT server, it is better to differentiate with ports other than the firewall's management ports, or use address groups is better because it is conflicted with firewall services and intranet servers who you want to translate the public IP to internal server IP. How to translate a public IP address into an unlimited private IP address beyond the port number 65535. The firewall uses the quintuple source port, source address, destination port, and protocol number to create and search the session table. Therefore, even if the source public IP address and source public port are duplicates, the firewall can find the correct session table and forward the corresponding packets as long as the destination IP address or destination port is different. When a NAT policy is used on the firewall for NAT, the IP address and port number after NAT may be the same for different flows. Destination IP address and destination port can be used in here too. When a NAT policy is used on the firewall for NAT, the IP address and port number after NAT may be the same for different flows. It is sending to the same internal hosts. Differentiate in the source port, but for the transferring port after NAT can be the same. what we see in menu to one NAT. What is the displayed information after the NAT server is configured and the global address of the firewall is traced? The global address of the NAT server is displayed during traced regardless of the number of hops on the firewall. If there are 3 hops, the global address is displayed 3 times. How does the user on the internal network access internal servers on the same network segment in the same security zone through public IP addresses? This is hairpinning. First, configure source NAT policy. The source security zone and destination security zone are both the security zone where the user and the internal server are located, and source IP addresses of the intranet user is translated into a public IP address. Then configure a NAT server to translate the destination IP address of the packet destined for the public IP address of the server into a private IP address. In hairpinning, configure source NAT policy. Source security zone and destination security zone are the same zone where the user and internal server are located, and source IP address of the internet user is translated into a public IP address. So we are doing source NAT here, and then we are doing destination NAT too. The public IP address of the firewall is translated to the internal IP address. We go with a source NAT, and then we come back with a destination NAT to the internal server back. This source NAT IP address and this destination NAT public IP address can be the same or different. We will look at this too in lab. This is the lab. This is the lab. Well, how can I do the lab? I can show you in here. This is the lab topology. This is server 1. This is server 2. I must make this. I must make this one. This is client 1. We will minimize it and we can open it when we use it. Now in ENSP, I can explain you. This client 2 is representing internet. Client 1 is representing internal client, and these are the servers. Firewall, this is the untrust site, this is the trust site. At first, we will look at this for this client 1 going to the client 2. At first, we just look to source NAT. What we will do, client 1 10.2.06 will go to the 5556, for example. The client 2 will send ping packet and it will be successful. Display firewall session table verbose destination global 5556. When we do this, we can see that in the verbose output, the system is public to public, the VSys. We don't use it VSys specifically. It is firewall's default public to public VSys. Zone trust to untrust. The received interface gigabit Ethernet 102. Sending interface gigabit Ethernet 101. Next hop 1112. Next hop MAC address is this one. You can see what is it in here. Then next hop ARP address, next hop gateway address, inbound interface, outbound interface, application, ICMP. We talk about this ASPF application layer gateway about SIP. It is written little character SIP. When the application recognizes that it is SIP, it is written in capital letters. This is we talk about. This we talk about. This is VSys. This is zone. This is life cycle. This is how many times left. In here, this is number of reverse packets. This is number of forwarded packets. This is IP addresses going to where, and this is policy name, security policy. We see all of them in here. This is the policy name, trust to untrust, we hit it. 10.2.0.6 client one's IP address. It is not translated to 1.1 and port translated to, you can see the source port is translated to more than 1048. It takes sequential first one upper 1049. This is for this intranet to internet, not this translation. This is for forwarding packets. This is for reverse packets. We can see this. We can do a insight. This is for source address translation. We can do a NAT server. How we do this source address translation? See from here. Not policy. This is our policy NAT 1, our source address translation. When you do display NAT policy rule all, you can see that this one is hit. Policy NAT 1, this one. And we hit it in the trust to untrust security policy. This security policy rule all. We can see it hit it this trust to untrust one. If we want to do a client 2 to server 1 access, this server 1 is HTTP, listening HTTP server and listening FTP server. Already it is started. IP address is as is. Server 2 is the same. FTP and HTTP. It is started. FTP started. This is listening. What we will do, display current config NAT server. What we write in there for NAT server policy NAT web, we make an address pool in here 11110. If we go 11110 8080, it will translate the traffic to inside server 1. If we do a 111.11.21, it will translate it to the inside server 2. Then when we try from the client to this one, 10.11.80.80, we can see it is correct connected. what we see in here, we do from 5556 to 11110 firewalls IP 8080 port. It translated to 1207 web port. Policy name untrust to trust. We can track it from here. Untrust to trust. Interface received 101. Interface sends 102. Next hop 10207 servers itself. This is next hop MAC address. This is the NAT policy. If we do from the client 2, we can see display NAT server, which NAT servers we have. 10 to 11110 to 10207 with port 8080. Again for FTP 1111. This is policy NAT web. This is policy NAT FTP. If we want to do for FTP access, from client 2 to server 2, this one. From here, we can say it is connected in here. Then we can do then we see again we do from 5556 to 11111. It is translated to server 2 port FTP, policy name trust to untrust to trust. We can differentiate from there. Display NAT policy. We can say that this is for NAT server policy. Which one is that? How we do that? Display this one. We can make this access possible for policy NAT for hairpinning. This one, when we come from the destination address 10.10.10 and 10.11, it's used the destination NAT address group. This is how it is working. If we come to the hairpinning now, then we go for the client 1. And make FTP access, for example, to 11110. This one. Or HTTP to 11110. This one can access. Again, we can use it. This is for hairpinning. What we will do in here, from client 1, we access it to the firewall 1's address group public IP from inside. Then it will translate it from this address group 80 to the internal server 2's 80 port. In here, we do from internal host to a internal host access with the public IP address of the server 2. If it's meaning like you directly do 10.2.06 to 10.2.08 directly internally, but we use this public IP address to using that, and we can see in here, we can see zone is trust to trust for hairpinning. Then the trust to untrust for hairpinning policy name, it hits. Then we can analyze like that. Client 1, if we want to access the, it can be with another IP address too, which is this one. So it is not needed to source IP address and your destination port will be this same public IP address. We can do it 10.1.1, 10.1, 10.10, for example, and we can design it for using ports 2. In here, this one. Here we use another source NAT, hairpinning 2 source NAT. So we come from internal server to here with 1.1.1.12. This is the source NAT IP address. Then we can do 1.1.10.10. We can translate to these ones, 80.80. Then it translates us to server 1's 80 port. So we can use port 2 to differentiate. It's not needed to just 1-to-1. We can differentiate it with ports 2. So this is the hairpinning. I can show you how we did this. Configs. This is for destination NAT. We use this for hairpinning. For this firewall's public IP address to internal IP addresses destination NAT. I am showing the specific ones. Another is normal firewall configuration, port 1 configuration. I make this R router with OSPF, subnet communication with OSPF. So the R router from packets coming back from R router to firewall 1's IP addresses. This is UNR root null 0 for the IP addresses we write. This is not server, I already showed this one. This is address pools of the public IP address. This is for hairpinning address pool to show source NAT and hairpinning NAT pool can be different. Here is the policies from, this is for source NAT. This is for NAT server. As you can see, always the private IP addresses. This is for trust to trust for hairpinning. For hairpinning, the source zone and destination zone are the same. Here is the policy is written again. This is for NAT address pool. This is source address. This is for both source NAT and both hairpinning. It can use this one. This is for hairpinning with different IP address. This is for source NAT. This is for NAT server. This is for NAT servers, NAT coming back to the intranet server. If your server wants over to your client wants default gateway is different, you can do untrust to trust NAT, and then because it seems directly connected, traffic come back if the clients cannot find the IP addresses of the destination. But if you do the untrust to trust NAT with the trust interface, then packets can turn back. This is for this purpose. And yes, okay, I think that is okay. I show what is my mind. Okay, we can come to this point now.
Okay, thank you. I just want to quickly do an overview of our enterprise support community. We are hosting this live webinar, but also other monthly webinars. For those of you who are not already familiar with the community, please know that this is the official Huawei enterprise community for all enterprise products, solutions, and certifications. You'll find an extensive knowledge base here. You can seek technical support by posting in the community. Our engineers and experts will help you get the solution very fast. We already have over 210,000 members, but the community keeps growing every day, and we are extremely grateful for that. And in order to make your participation in the community even more exciting, we've prepared an entire reward system, which includes high coins, the virtual currency of the community, online shop with different redeemable gifts, but also symbolic appreciation gifts such as badges and the newly Hall of Fame, which shows you the most active, the most dedicated users of our community. Some of them are here in the webinar, and I want to personally thank them again for being our elite users, our most active users who are always helping others and always supporting us and paying attention to everything that happens in the community. So thank you guys for all your help and support. And last but not least, we have monthly webinars and activities like you can see here. Including this webinar, we'll have 10 Amazon gift cards for 10 external users who replied to the following questions correctly. Before we go to the next slide, I just want to send some useful links here in the chat box. In case you have not already subscribed, I recommend you all to subscribe to the content that you are interested in, so that you don't miss out future webinars, activities, and so on. And please, if you are interested in joining the Q&A session, go to this link and leave your answers there after Serhan presents the 3 questions. Now we can go to the next slide, Serhan. Okay, so this is how the webinar post looks like in the community. That is the link to the post, which I've already sent you in the chat box. So in the next slide, Serhan will present 3 questions, which I will also post in this post in the community. If you want to get a chance to win, I invite you all to access this link and leave your answers there. After the questions, if you have any other questions for Serhan, please leave them in the chat box as well. If not, I will see you in the community. And I want to thank you again for participating, for joining our session. And I hope to see you all again soon. Thank you and have a nice day or evening, depending again on your time zone. Thank you, Serhan, and thank you all for joining. Now we can present the 3 questions, if you can read them, and after that we will end the session.
Okay, I open question 1. When you configure NAT server, the destination address specified in the security policy is a private address after NAT, not a public address before NAT. Everybody can read and understand, I think. I am going to second one. Transport mode, service interfaces working in switching mode. Supported addresses in the address pool and outbound address interface can be used as the source address after translation. Supported, but only the addresses in the address pool can be used as the source address after translation. The outbound interface address cannot be used as the source address after translation. Supported, but only the outbound interface address can be used as the source address after translation. The address in the address pool cannot be used as source address after translation. They're not supported. I think you can read. Give 5 seconds more. Question 3. In that scenario, in which conditions black hole route of the public address needs to be advertised? This is a multi-choice. The address pool and interface address of the firewall are on the same network segment. If address pool and the interface address of the firewall are on different network segments, in the same network segment, firewall directly sends an ARP request packet to request the ARP of the address in the address pool. Apparently, no one responds to ARP packet and the packet is discarded. Therefore, blackhole routes need to be configured in the same network scenario. On different network segments, you requested from, I think, all the presentation in forum 2. On firewall network segment, when the public network packets whose destination address is an address in the address pool reach the firewall. If no session is matched, the firewall forwards the packet to the route. If the firewall finds that the address pool and the interface address are on different network segments, the firewall generally matches the default route and sends the packet to the next hop router. The next hop router searches for the route and sends the packet back to the firewall. As a result, a loop is formed between the firewall and the router. The packet is discarded after TW is 0. As a result, bandwidth performance are bested. Therefore, blackhole routes must be configured in this scenario. I think it is obviously straightforward. If you cannot understand anything, please ask, or if you cannot read, preach.
Okay, so I've updated the post in the forum. If you want to start replying, you can do it there. You can find the questions already updated. If you still have any doubts or questions for Serhan regarding the questions, if anything is unclear, please let us know now. If not, we will end the session, and thanks Serhan again for his time and for sharing so much knowledge with us.
Well, if it is beneficial, glad to hear that.
Yes, I'm sure it is, and I'm sure our users have a lot to learn from you.
For the ones who already know, I think they are in the same level, but the ones who don't know, it takes really too many repeats to learn like that and come this point.
Yeah, I think our users have different levels. For some of them, it might be easier to understand the content. For others, it might be a lot of information to take in. But even so, we will have the recording in the forum, so those who are interested in this topic will be able to see this training in the future as well, and check it out when they are preparing for, I don't know, maybe a Huawei certification, or maybe they are dealing with something in their day-to-day work. So I for sure think that there's a lot of useful information here for many of our community users. So I want to thank you again for accepting the invitation. And thank you all for attending. As I said, I invite you to go to the forum, leave your answers there. We will select 10 users. And if you have any questions left, you can also post them there. I left the link one more time just to be sure that everyone has access to it. Okay, thank you all. Have a nice day ahead, and see you soon. Stay safe and healthy. Thank you. Thank you all for your feedback. The recorded video will also be updated in the forum post that I already sent a few times. So I will make sure to update the post again and add the recorded video there. So everything will be available in the forum. Okay. Also, if you want to get a notification from me when the recorded video is available, you can send me your email in private, and I will let you know. Okay. Thank you.
Thanks. How to check? How to check? I think they are asking forums page.
Yeah, it's the link I've already sent. And I will update the post to add the video as well. But first I need to upload it on YouTube as well.
Okay, I think they can follow it from the forum. Can't mention email ID of yours. I think they can understand from the forum. No need for email ID.
No, we don't have to leave any email address. As I said, everything will be available here in the forum, so just please please follow the forum post. You'll have the video there, the presentation, the questions are also there in the post. So okay, I received a few email addresses. I will send you a notification when the video is available as well. Okay. This was it for today. Thank you all again. Have a nice day ahead or evening. Bye-bye. Thank you, Serhan.
Thank you. Bye-bye.
Thank you.